Hello everyone, we are back. So before we start, I'd like to say if I've made a mistake or if you have any questions, leave a comment so we can work together on answering these problems. In today's problem, we have this question. Here we go. A car is traveling along a straight road at a velocity of 27.9 meters per second when its engine cuts out. For the next 2.51 seconds, the car slows down and its average acceleration is a1. For the next 6.03 seconds, the car slows down further and its average acceleration is a2. The velocity of the car at the end of the 8.54 second period is 14.9 meters per second. The ratio of the average acceleration values is a1 divided by a2, which is equal to 1.96. Find the velocity of the car at the end of the initial 2.51 second interval. So that was a lot. I already went ahead and put down everything we know right here. So here we know our starting velocity is 27.9. For part one, I've separated into part one and part two here, and we'll kind of fill it out as we go. So V naught 1 is equal to 27.9. If you don't know, I'm saying not, and that kind of I'm referencing this little circle right here. That all that means is it's the beginning, it's the first part. You could say I instead for initial. Whatever your notation is, just know how to do it. So our first velocity is 27.9, then we have V1 right here, and then this entire interval right here is 2.51 seconds. And so for part two, we don't know the initial velocity, and if you'll notice, we don't know either of these. We don't know V1 or V naught 2. Because they are the same value, it's the exact same point. As soon as part one ends, part two begins, and so that's why those are the same value for the ending velocity in the entire problem, and for part two is 14.9 meters per second, and the time interval in part two is 6.03 seconds. So that's everything that we know. And don't forget this is very important right here. The ratio that they give us, A1 over A2, is equal to 1.96. So we're going to go ahead and get started with the math. I'll do the math in front of you. My calculator is right there. So we'll start with A1 over A2. You have to remember this. So I'm going to go ahead. To find the acceleration for A1, we're going to take V naught 1, and we're going to subtract V1 from it. What we're going to do is take V1. We're going to take the final minus the initial. So we're taking V1 minus V naught 1, and we're putting it over time. And that is A1. And A2 is the same exact thing. We're taking V2, the final velocity, minus the initial velocity for part 2 over T2. So now that we know this, we can equate that and fill these in, and we can equate it to 1.96 since A1 over A2 is equal to that. So we'll go ahead and write that out. We have 1.96 is equal to A1 over A2. And now we can fill these in. We could put this for A1 and this for A2. 1.96 V1 minus V naught 1 over T1. And this whole thing is over V2 minus V naught 2 over T2. Over that whole thing, right? That's a lot. We are right here right now. Kind of looks like a lot. So we're going to move on to the next part where we're going to fill all of these in, right? And since we don't know these, I'm just going to put a V because they are the same. V1 and V naught 2 are the same number. That's what we're trying to figure out. So I'm just going to put V as what we're finding. So when we fill everything in, we should have V minus 27.9 over 2.51, all of that over 14.9 minus V all over 6.03. There we go. So this is what we have. And don't forget, this is all equal to 1.96. I'll put 1.96 over here on the side. So this is where we are right now. I'll go ahead and get another, I will flip this over and then we can continue with the problem. So remember that we have this. Notice we have two fractions here. And how do you divide a fraction? Well, you multiply the numerator by the reciprocal denominator. Okay, so I've gone ahead and wrote it out right here on the other side. If I flip this over, you'll see that we have this. We multiplied the top by the reciprocal. Right here is the reciprocal. So now that we are at this point, we need to know, well, how do we multiply fractions? Well, we multiply across. So we would take 6.03 multiplied by 27.9 and by V, and same thing right here, 2.51 times both of those. So when we do the calculations, we get 6.03 V minus 27.9 times 6.03, 168.237. I'm going to go ahead and write out these decimals right here, and that is going to be over 2.51 multiplied by 14.9, and we get 37.399 minus 2.51 V. And all of that is equal to 1.96. I kept writing 1.96 because this is when we're going to use it now. We have this in the denominator. Now we're going to multiply. We're going to take these numbers out of the denominator and bring it to the other side. So we're going to multiply it by 1.96. So we'll take 37.399 multiplied by 1.96, and we end up with 73.302. And now we're going to do the same, and we're going to multiply by negative 2.51, this right there. 1.96, and we end up with negative 4.9196. So I said negative, that's just the minus sign, and so I just put the minus sign right there. So now we have these over here. Oh, can't forget the V. Now we have these right here, and now we're just going to combine like terms, and that will get us, we're going to add this to this side, and we're going to add this to this side. So this plus 6.03. We now have one. Oh. Now we're going to do 6.03 plus this number, 4.919. We end up with 10.949. And then we're going to do the same with the other side. There's a V right there. 73.302 plus 168.237. We get 241.539. Now all we have to do is divide to get V by itself. So we're going to divide by 10.949 and then divide it on the other side as well. That should get us our velocity, which is equal to 22.06, and that is in meters per second. So when we look back at our diagram right here, at this point, V1 and V02, at the end of 2.51 seconds, the car is traveling at 22.06 meters per second. I hope that helped. If it was a little confusing, go ahead and watch the video again. But please like if this was accurate, so that way other students know that this is helpful, and so that way we can help more students out with problems like these. I hope this helped.